Okay, good morning, all of you. Let's continue our theory class. In our last class, our last class, then up to this. Okay, BSS. Under this BSS, we have different type of different types of subsystem base station subsystems. Under this the different type. This BSS is act as an interface between the mobile stations. Mobile stations means what? Our mobile phone. Okay, mobile stations and the network systems, network subsystems. Network subsystems, we can say that it doesn't include network systems, doesn't include this MSC and other. Okay, MSC and others. So subsystems under this the base transceiver stations, and then base station controller BSC, which control the base transceiver stations and act as the interface between the mobile stations and the this is the intermediate system. Okay, this BSS. And the next point is the network subsystem provide the basic network connections to the mobile stations. The basic part of the network subsystems is the mobile services switching centers, which provide access to different network like ISDN, PSTN, etc. It also consists of the home location register and the visitor location registers, which provide the call routings and roamings capability of a GSM. So these subsystems also having the same some of the same process of the MSC. Okay, MSC, main switching center. It's having this ISDN, means integrated digital network services, digital line, and also PSTN means public switching network, like telephony networks, like landline numbers. Okay, in our normal communications, we have a telephony system. So using this telephony system, normal telephony systems, we have landline numbers and the booth and the phone numbers. Then if you dial the numbers from the phone booth, then it's going to the main main switch exchange. Then exchange switch connected, okay, redirect your call based on your number dialing from your phone booth. So this systems is called the exchange. Okay, exchange switching over to your request number, then it's make a switching, okay, circuit switchings in the exchange. Then you have a dedicated connections. Okay, once you connected to your party, another party number, then your line is your line is dedicated with your partner. Okay, there is no chance of connecting to your connections. The line is engaged for you and your friends or your party which you are calling, which you are connected. Okay, this is called the PSTN. And also having this SLR and VLR, visitor locations registers and home location register. Okay, these are the subsystems, and under this BSS, we have the main element of the GSM architectures. Okay, BTS, base transceiver stations. If you go out from your home office, if you look around some high level, a mountain, or maybe a little bit higher than your stations, then you can notice that there are different types of steel structure tower with horn type antenna. There are different types of uh, antennas mounted over there. So this is called the BTS, okay, base transceiver stations. Okay, so this is BTS, you can say. Okay, we can continue now. BTS is the base transceiver station. It is the base transceiver stations. This is include the antenna and tower, steel structure. All these things are the BTS. Okay, which utilized within the GSM network includes this radio. Okay, for the radio transmissions, well as transmissions for the transceiver and receiving. Okay, TX and RX. They related antennas to transmit this receive or direct converse through the mobiles. So all our smartphones and maybe a 2G or 3G or 4G or 5G phone always communicate with the BTS first, the first point. Okay, the first point connected to the system. Okay, okay, and these stations is this stations is very important element for every cell, and it's converses with the mobile, and the interface among the two is identified like UM interface with related protocols. Okay, then it's having some communications with the mobile stations. Okay, BTS is very important. This is the radio transmission and receiver, radio TX and RX for wireless communications, and also it's maintained the cell also. And the first unit, then we already discussed about the cells, and also how to use this how to reuse the frequency, how we are going to this hand off and all these things we already learned in the first unit. Then this is the main part of this cell. Okay, this BTS is very important. Okay, anyway, let's move on to the next slide. Okay, let's see here. In the main element of the GSM architectures, that's BSC, okay, base stations controller. In this base station controllers, we have different types. Okay, before this, let's see this BTS base transceiver station or base terminal. We can say this MS. Okay, see this point. This MS here, mobile stations communicate to the towers. Okay, and all these towers can join together in a single BSS. Okay, base stations subsystem. Okay, so these base station subsystems can control multiple tower or multiple cell, we can say, or a single cell can have a one BS okay, BSC, base station controller. So these are the communication system. Okay, so BSC, let's see. BSC BSC is used to form a next phase reverse into the GSM. reverse into the GSM technology. This controller is used to control a collection of base transceiver stations, and it is frequently correlated to one of the transceiver stations within the group. Okay, this controller manages the resources of radio to control different items like handover in the collections of BTS based transceiver stations. If we are moving one cell to another, we need to manage that some techniques. Okay, this type of the kind of assigned channel. It conversed with the base terminal stations over the ABIS interface. Okay, that's different types of interface are requests for the cell to cell. The sub element in the base stations of the GSM networks use the radio allowable technology to allow number of operations to write to use the systems concurrently. Every channels support up to 8 operators. So from the tower we have our channel allocations. Okay, frequency channel allocations. So from these channel allocations, then it can operate a 8 number of users over base stations. It includes different channels. Okay, the huge number of operators can be accommodated through every base station. So this subsystem manages the allocation of the channel also. Let's move on to the MS mobile stations. It is the mobile phones which consists of the transceiver, the display, and the processors, and it's controlled by a SIM card operating over the network. Last class, we already discussed about this how the mobile stations activated by the SIM card. Okay, what are the things inside the SIM cards? This is the one of the informations available in the SIM card is the KI key, okay, network key, to encrypt all the registered informations, and the communication also. Okay, it's needed to encrypt. Otherwise, if it is a wireless communications, there's lots of there's chance of intercepting the network. So we need to have integrity. Okay, you need to have integrity. To do so, we need encryption to have integrity in the communications. The mobile stations and mobile equipments are most generally identified through the cell. Other ways, mobile phone which are part of the GSM mobile communication network. Okay, sorry. That the operators observes and operates. Wait. Okay. These MS mobile stations and ME mobile equipment are most generally identified through cell. Okay. Otherwise, mobile phones, which are the part of the GSM mobile communications network that the operator observe and operates. At present, these dimensions has reduced radically, whereas the functionality level has very much increased. And one more benefit is the time amount charges has drastically enlarged. These are different elements to the mobile phones. Though the two essential elements are the hardware and the SIM card. So for this MS or ME, mobile stations or the mobile equipment, this is the part of the GSM networks in the GSM dimensions. And without this MS and or ME, mobile equipment, then that's cell and communications cannot happen, cannot implement. Okay, this is the main part, the last part. This is very, very important. And the elements in this MS and ME is the mobile hardware and also included the SIM card to activate to the network. The hardware includes these major elements of the mobile phones like the case display, batteries, okay, this processors, electronic equipments, signals receivers, all those things are included. And also the main important part is the IMEI. Okay, IMEI. What is the IMEI? IMEI is the numerical number systems to identify the particular mobile phones. Okay, particular mobile phones. I already explained this. What is the working of IMEI? Then what is the use for checking all these things? Then we already discussed in the last class also. This can be set up on the mobile phone while manufacturing and it cannot be modified. So it's clear that this IMEI is very, very important to identify the mobiles, where it's located, and who is the owner, and all these things. Not the owners. Okay, identifying the mobile stations, whether uh, whether it's in the moving positions or what is executed from the ME or MS. Okay, and then it's all these communications is based on this IMEI. Okay, identification number. Okay, and let's move on to the next element of this GSM. In this GSM communications, we have this operations and support system. Under this operation and support system, the complete GSM network architectures is complete. Okay, it can complete this entire GSM network operations under this OSS. Okay, operations and support system. This is connected to the NSS and BSS. Okay, network subsystem and BSC component. These operations and support subsystem is mainly used to control the GSM network and the BSS traffic load. Okay, it's maintain the GSM network. Okay, GSM communications and base station subsystem traffic load. So if there's lots of large amount of mobile device communicate to the particular towers, okay, maybe a high traffic, then it can slow down the services, the bandwidth and all. So this OSS is monitoring those things, operation and support subsystem. It should be noted down that when the number of BS enhanced through the subscriber population scannings, then some of them are preservation tasks to move to the base transceiver station so that the owner cost of the system can be reduced. So this OSS manage that subscriber. Okay, subscriber, it's very huge and very populated in some area. So it's manage those subscriber if it is in a huge populations or huge traffic. then it can divert it to the another BTS, okay, base transceiver stations. Okay, let's move on to the next topics. Radio, GSM radio subsystem. This radio subsystem is comprises all the radio specific element. So it concern about the wireless communication in this subsystem. Wireless communications, radio communications, that is mobile stations and base station subsystem within this wireless communication. The communication between the radio subsystem and NSS via a interface, okay, and the connection of the OSS via O interface, okay, operation interface, that we can see in this. Okay, we can see in this signal dotted and all these things, dotted line, solid line, and the A interface is generally based on the circuit switch PCM 30 system, okay, and carried out of 30x64 kilobit per second connections, whereas O interface uses signal systems, okay, based on the X25 carrying system management of data to and from the RSS. Okay, so these are the radio frequency and the bandwidth allocations for these mobile stations and the BSS, okay, base station subsystem. And in this we have OSS, and also we are having this pulse code modulations for modulating the mobile voice communications, or maybe switching to one from my mobile phone to communicate with each other based on the subscriber number for switching this PC system. And also this for data connections is needed to 30x 64 kbps per second connections, and other signaling systems, it's based on this X.25 communications. This is the digital communications, data communications, okay, data transmissions, not the voice, okay, for data transmission. Okay, and let's see, this is the GSM radio subsystem based on the functions where it's executed. Okay. Where is executed those things, those functions in the base transceiver, base terminal stations or transceiver stations, or the base switching center BSC. Okay. Management of radio channels, allocation of radio channels for the operator, all these things we will discuss in the last unit. Those management of the channel, okay, management of channels done in the BSC, okay, base stations controller, okay, BSC, and frequency hopping, okay, that's how to hop the frequency hopping, already completed in the last class how is hopping. This is done in the BTS and the BSC also. Management of terrestrial channel. Terrestrial channel is the all those things, tower and all, is the terrestrial tower, okay, those cells. So how to manage those channels, frequency channels, it needed to be different from one cell to another cell. And if we are using different cell for the entire network, then we need to have different types of frequency allocations, and also it's become a very complex. So it's coming this frequency reuse in this management of terrestrial channels. So terrestrial channels is needed to up uh, uh, to up the towers. The we need to have frequency allocations. Okay, and also we needed to have frequency reuse. So this is done in this BSC. And mapping of terrestrial onto the radio channels is done also in the BSC. Channel coding and decodings also in the BTS itself. Okay, encoding and decoding, this is part of the encryption. And rate adaptations. Okay, this is also done in the BTS encryption decryption. This is also part of encoding and decoding. This also in the BTS itself. And picking on the BTS uplink signal measurements also in the BTS, traffic management in BSC, authentications also done in the BSC, location register update, handover management, all these things are in the BSC. Okay, these are the things in this GSM substations, subsystems, radio subsystems. And let's go to the GSM channel types. Okay, what are the channels in the GSM? This divided into two types. One is the traffic channels, TCH, traffic channel, and another is the signaling. Under these traffic channels, that traffic channels are intended to carry encoded speech or data. Okay, this traffic is it's concerned about, okay, concerned about this speech and user data. Traffic channels are intended to carry encoded speech. So these are the encoded and decoding is very very important in this. In the last discussion of this radio GSM radio subsystem, which encoded speech and user data, full traffic rate channels at a net bit rate of this 22.8 kilobit per second. Okay, KB. It's very slow connections in this GSM. Okay, half the rate traffic channels at a net bit rate of 11.4 kbps. Okay, so this is a net bit rate. Okay, and speech channels are defined for both full rate and half rate traffics. Okay. So the previous one is the full rate 22.8, and the half rate communication is the 11.4 kbps. So data channels support a variety of data rates. This can be 2.4 or 4.8 or 9.6 kbps, and both half and full rate traffic channels. So it's having this both the full rate and the half rate communications. So this is traffic channel. In these traffic channels we have two types, full rate and half rate. Okay, full rate channels having the rate allocations, and the half rate also this rate allocation is there. So it's communicated based on this. Let's move on to the GSM channel. The traffic channels support two types of information rates: full rate and half rate, based on this. Because when transmitted a full rate, the user's data is occupied with the TS per frame. Okay. When transmitted as half rate, the user data is occupied in the same time slot but sent in alternative frame. Okay, that's time frame. Okay, that the time frame it's allocated in a full. Okay, that's frame. Frame is the like a packets sending from this from my mobile stations to the towers, and from towers to the BSC, MSC, all this sending along to the using this in the form of frame. Okay, if it is full, then it's using the full frame allocations, but if it is in a half, then it's occupied one frame, then another frame, another frame can be used by the another person. If it is half rate, then it's occupied alternative frame. Okay, alternative frame. The 26 frame contains idle bit if it is full rate. Okay, in the 26th frame that contain idle bits, if we are using this full rate continuously the frame. Okay, TCH are used and contain this SSCCH data in a half rate in the TCHS are used. Okay, what is this SSCCH? This is low associated control channel. Okay, this is low associated control channels. And the TCHS means what? This is the traffic channels. Okay, traffic channels. So this is controlled by this okay, this SCCH controlled by the TCH. Okay, slow associated control channel. Okay, then we can move to the full rate TCH data and speech channels. In the previous, we already discussed this half rate, and here in this full rate we have the rate speech channel. Okay, in the full rate at 16 kbps, the full rate speech channel is digitized. Digitized means there is no analog communications, it is fully digitized. The full rate speech channels carries 55.8 kbps after adding the GSM channel coding to the digitized speech. Okay, it's digitized with the data channel. Okay, full rate full rate data channels of the 9600 bps bit per second. The full rate traffic data channels contains raw channel that is transmitted at 9.6 kbps after the operations of the additional forward error corrections coding with the GSM standard. 9600 kbps is transmitted at 22.8 kbps. Okay, so another things in the C, full rate data channel for 4500 bps. The full rate traffic data, sorry, not the date, it's a mistake. Data channel contains data bit is transmitted at 4.8 kbps after the application of additions toward error corrections coding with the GSM standard. 4.8 kbps transferred at the 22.8 kbps. Point D. Full rate data channel of the 2400 bps. So data channels, the point number is speech channels and others is the data channels. Okay, different types of allocations are there: 9600 and 4500 and 2400 bps. And in this 2400 bps, the full rate traffic data channels contain raw data that is transmitted at 2.4 kbps after the application of the additional toward error corrections codings with GSM standard. The 2.4 kbps data is transferred at the rate of 22.8 kbps. Okay, the speed and the data. Okay, the data size and the speed. Okay. Okay, let's move on to the half rate of the TCH of data speech channel. Half rate data in speech. In the speech channel of the half rate, the half rate of speech channels can be carried digitized speech that is sampled at the rate of half of full rate channels. GSMs anticipate the availability of the speech coder. It can digitize speech at about 6.5 kbps. After adding GSM channel codings to digitize speech, the half channel speech rate will carry 11.4 kbps. So it's needed to digitize our voice communications. Then after digitize this speech, then it comes this 4.5 kbps. After adding the GSM channel, so to add to the GSM channel coding of the digitized speech, then it's come this half rate speech to carry those speech digitized informations. It's in the 11.4 kbps. And in the half rate data channel of the 4800 bps, the half rate traffic data channels carries raw data that is sent at the speed of 4800 bit per second after the applications of forward error corrections using this GSM standard. 48,000 bps data is sent in the 11.4 kbps. So this is the speed of the channel. And the next one is the 2400 kbps in this half channel. Okay, half rate channel. The half rate channel traffic data channels carry raw use data that is sent at 2400 bit per second after the application is added forward error corrections. Okay, after adding those error corrections using this GSM standard, 2400 bps data is sent in this same speed, 11.4. Okay, so we're done up to this slide, 33 slide. Then we'll continue it in the next class. That's all for my preparation for today, and I'll take the attendance. Kumha, it's applying leave for today. And other, is there any application for today? No application for today. Today is 17.